We're in big screen, notas. Muchas gracias. Full screen. 2.1, we're hit. So chapter 2. Chapter 2 is loaded with stuff you already know. We're going to play it. Mr. Adgerley! Oh, no. You know what it is. My Secret Service requirements. I cannot be disconnected from the president at any time. What are you doing over here?
I got 10 minutes, so I gotta hurry.
You guys know Mr. Edgerly? Anyone know Mr. Edgerly? Yeah, these guys. So, Mr. Edgerly, welcome to my video. You can see it later. I'll go on YouTube. Yeah, we're recording notes daily.
Hello, in the future.
Oh, in the future. We're trying. Back to the Future. Did I show you guys the Back to the Future clip yesterday? That was your class, right? You are such a... Who was that? I know your plot. You want me to show you again and waste more time. I am so onto you. My word. I didn't show you? You're not kidding? So Talia, you were just telling the truth? And I was making fun of you? I am so sorry. I will show you the clip I showed the other class, I promise. And if we get to 5 minutes left and I haven't shown you this, you must make me stop. I'll just stop cold. Okay? All right, back to work. So linear and quadratic functions in modeling. This is awesome. Gotta love this. The modeling part is, I did some shopping recently. So to break up all this math monotony, once in a while I'll just whip out one of my new shirts or something, show it to you guys. It'll be awesome, okay? So linear and quadratic functions in modeling by Mr. Seeley. Okay. My first modeling effort, the hoodie. Later. Again, hold on to your seats. Polynomial, that is, let n be a non-negative integer. Oh my word, this is mathematical. You got to read. This is good stuff to learn how to read. Let me help interpret it for you. Let n be a non-negative integer, and a naught, by the way, a sub 0, that's called a naught. Like there's got not in there, nothing. A1, A2, on up to all those stuff. What that actually means is that n, the little exponent that you see repeated over and over again in some form, n is a non-negative integer, means it's never a negative number, and it's always like 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. Sometimes we call those whole numbers, by the way, non-negative integers. Those are awesome. The next piece is there is a leading coefficient. There's some key terms we want to know, like, oh, you know, leading coefficient. We'll define that in a couple different contexts, but that's really important. Sometimes just called the coefficient, but the leading coefficient goes next to the highest power of that polynomial. Oops, I just wrote highest. Okay, by the highest power of the polynomial. Okay, that's where we have it. Let me interpret in context now. So that thing up there and all that symbolic notation is just a polynomial with some degree, and the leading coefficient is the number that's next to the highest power of x. Okay? Things like, hey, if you have a polynomial, it's equal to 0. Its degree, we would say, is undefined. Degree is the highest power of that particular polynomial, like I just mentioned before. So you want to put that in there. And green is not working for me. Let's go back to pink. So highest power is what a degree is of the polynomial. So when I look at f of x equals 0, it's undefined. We can't actually give it any kind of degree. But when f of x equals a, another way to look at that one, that middle box on there, a is also the same as a times x to the 0. And if you remember, x to the 0 is the same thing as 1. That would be degree 0, because it's x to the 0 power. It's like that's its highest power. So when we see just plain old f of x equals a, we're ignoring the x to the 0, which we already know means 1. Okay, that's why it's called a degree 0. We will not write x to the 0. We don't need to. ax plus b, you might not remember that there is a power of 1 written right in there. Well, it's usually not written, but it is a degree 1. That's an exponent of 1. ax to the first is the same thing as ax. And then plus b is a constant. Next one is degree 2, because the highest power in that polynomial is 2. So we say degree is the highest power of that particular polynomial. But that's some details, hopefully bringing back memories, fond memories of your past. That examples in number 1 we have, are they a polynomial function? I'm losing my voice in really weird ways. Excuse me. Oh, that was awkward. So determine if the equation is a polynomial. Ugh. And then if it is, identify the degree and coefficient, like leading coefficient. How about this? I want you to hold up fingers. This is actually a dexterity test. 1 through 4, I want you to hold up, let's say A is 1, B is 2, C is 3, and D is 4. Hold up the fingers of those that are polynomials. Try it. This is good. You can do it. You gotta hide your phones for a second. Okay. Hold up the fingers of the ones that are polynomials. Ready? It's 1, 2, 3, 4. 1 or A, B, C, D. A, B, C, D. Got that? You ready? How about this? There's more than one. You ready? This is good to know. Want to know the correct answer? Yes! Joey's got it. Hang loose. Where's that love? Rock and roll?
Devil horns.
Oh, good grief. Oh, yeah, Texas. Oh, no. Really? All right, we got that. The end ones, A and D are polynomials. The others are not, and I'll tell you why. Good. That was actually kind of slick. You guys are like that? Okay. A, we've got a polynomial because this is the definition up top. I'm going to go back there and highlight this thing. Get a little yellow going on here. It's got to be non-negative powers in order of non-negative integers in order to be a polynomial. Well, as I look through this, there's powers of x. That's to the third. That's to the first. Non-negative integers, polynomial. So the first one's totally a polynomial. Its degree then, since it's asking for that thing, degree would be the highest power you see in there, which is 3. And then it asks its leading coefficient. So next to that highest power of x is 4. That's it. So A's got degree 3, leading coefficient of 4. What's the problem with B? Why ain't B a polynomial? Yeah, negative. It turns it into a fraction. A negative exponent does turn it into a fraction. Just knowing it would be this 6 over x to the 4th if I took away the, use the negative exponent, which does the flippy thing. This is the equivalent expression, which then you go, oh yeah, that's not a polynomial. That doesn't work. But you can go ahead and go by the definition, non-negative integers for powers of x. Failed that in part B. C, this one's tricky. There is a big, huge warning we need to put on here. Are you ready? Do you like warnings or like do nots? Do not do what you probably want to do. Split up the radical when there's a plus or a minus sign. Never, ever, ever is that allowed. Never allowed. Oops, I need to make room for my radical. I mean, radicals are radical and all, but they're not that radical. You can't do that. Don't do it. So get up my bloody red. No. What you can do is you can try and split it up by multiplication. You can do a little factoring. This is okay, but you'll find out this is why it's not a polynomial, because you can't split it up. If you did that do not rule, that big naughty thing there, you would have gotten a polynomial probably. But it's not. What happens, I can try and factor stuff under there, like the x squared that I can get out of both of those. That's cool. I'm going to pull that out, x squared, and it leaves me 9x squared plus 16x, no, 16. And that's nice. That is something I can take the square root of. You can split up a square root around multiplication, but not addition and subtraction. So I can take the square root of that radical x squared and then do radical of I can do these separately, radicals of each. Square root of x squared, you guys know is x. Well, plus or minus x. And then the square root of that expression, I don't know. I just rewrite it. But you cannot split it up around that plus sign. Never. That's it. That is all we can do. And it's pretty evident at that point. This is not a poly. No way. Not a poly. In B, I didn't write that explicitly, not poly. And then we got to get to, I told you D was one of them. That was one of our horns. That one totally passes. Exponents of our x's are 1 and 4. Positive integers. We're home free. So we want to write its degree. Degree is the highest for the leading coefficient. Be careful. It's not 2. What's that? It's not 2. No, I think it was second block. See, I'm having issues. It's Friday, and I'm starting to forget what I told blocks. Did I tell you the song my mom taught me? Okay. Just so you know, I have maturity issues, and it comes from somewhere. And I should tell you, my mom taught this song to me many years ago. Picking their nose, they're doing it, doing it. Picking their nose, they're chewing it, thinking it's candy, but it's not. Did you catch that? Thinking it's candy, but it's not. Get it? It's a little bit of play on. Oh, okay, yeah. See, my mother taught me that. True story. She might actually see this on Twitter too, the video. Mom, that one's for you. My brother sometimes will post on Twitter like, I really don't care about your stupid math videos. You know, that's his tweet he'll put on there because he sees them. They go on my Twitter account. You guys do not have to look at my Twitter account, but once upon a time I set that as my default to have all my videos that I record go into Twitter. And so now they do. They just constantly automatically upload on there. I'm not going to change it. Might as well go there. If I have anything to say, I say it to you guys. Just so you know. 2a, -1, 2. That notation is actually the same thing as saying the point -1, 2. And in that second piece, that 3 in the function, what it's saying is, I'm going to put 3 in the function and get out -2, or I'm going to put -1 in the function and get out 2. That's actually the definition of a coordinate point. If you didn't know that, it's actually good to know. A coordinate point says, when I put in this number to a function, I get out this. Now, let's talk about a particular kind of polynomial. So we just got done with the poly, no poly. And when it is a polynomial, its degree and its coefficient. We're going to transition to, for a couple of days, linear equations, which we know pretty well already, but we're going to enhance your knowledge. So lines are polynomials of degree 1. One of the things you have to know is how to come up with the equation of a line between 2 points. So this is a little recap, going back in time and introducing you to this wonderful new notation for a coordinate point. That's the same thing as -1, 2, and 3, -2. We're going to find the equation of the line, as the instructions say, that go through that point, and the 2 others afterward. But I want to bring back your favorite linear equation, this one. It's called point-slope form. This is the one where you have a point and a slope. Y minus y1 equals m times x minus x1. Not the same as slope-intercept, the mx plus b, that we use a lot for graphing. That's a really big advantage there. But this guy is for finding an easy place to stick a point and a slope. When we have this, 2 points, we always start with go get the slope. Then we'll plug in a point and finish this equation. Slopage is, you got to go in and subtract y2 minus y1 over x2 minus x1. You know that formula. It's change in y. I'm going to go -2 minus 2, which means I have to do the x's in the same order, 3 minus a -1. The formula says to subtract. If that happens to also include a negative when I'm subtracting, like my number is negative, that's fine. You would have to have minus a negative in there. So I subtract those two. Negative 4 over 3 plus 1 is 4. So we get negative 1.